Hello guys, let's start off with the program number 3. Now we're going to discuss about number series. So in this program we're going to discuss about 3 different number series. The first one is number series with a twist 1. This is the series which is given here. Let's have a look at the series, which is 00, 76, 14, 12, 21, 18 and 28. In this series we have to find out the 15th term of it. If you look at the series, you can see the odd terms are incremented by 7. Now what are the odd terms here? 1, 3, 5, 7 and so on. Let's look at the odd terms here. Say 0, 7, 14, 21, 28 and so on. And the even terms are incremented by 6. Let's have a look at these even terms: 2, 4, 6, 8, 10 and so on. So if you have a look at this, 0, 6, 12, 18, 24, 30 and so on. So now what we have to do, if it is an odd term, we have to increment the number by 7. If it is even term, we have to increment the number by 6. So this is how we have to construct the program. Is it clear? Now we'll go and look at the program once. Now this is the program. See this. We're going to start off with the main function and we have declared some variables. This is I, which is used for loop, and n is a term which we have to find out, and a equals to 0 and b equals to 0. We're going to initialize that a and b values as 0, where a is going to represent the odd terms and b is going to represent the even terms, right? So now first of all we have to take n value. This n value represents the term which we have to find out. If you look at this question, the term which we have to find out is the 15th term, right? So now the 15th term we have to find out. So n value is going to become 15. And as usual, the for loop which represents for I equals to 1, I less than or equals to n and I plus plus, right? So we're going to start off from 1 to 15. So that's where the condition is I is less than or equals to n. So initially the condition is going to become 1 is less than or equals to 15, right? And I value is going to keep on incrementing until this condition goes false. We have to iterate inside this for loop, right? So we have to figure out what is the 15th term of this series, where the initial I value is 1. So instead of going with the 15th value, let's say we'll figure out what's the 9th value first, so that we can summarize the program much quicker than the 15th term, right? Let's see here, the 9th term of this series is 1, 2, 3, 4, 5, 6, 7, 8, 9, 28, right? So let's try to run this program and let's see what is the 9th term of this particular series is, right? So let's run this program and have a look at this. What is the 9th term of this series? Okay, so enter the number, is the n value, 9th term, and you can see 9th term is 28. So it is running fine. Okay, so n value is 9 and we have done the condition. And how can we figure out whether it is an odd term or even term? Is by using this condition. If that I value is if it is divisible by 2, we can say it's an even term. If it is not divisible by 2, we can call it as an odd term, right? So now here initial I value is 1. So 1 modulus 2 not equals to 0. That means it is true because 1 cannot be divisible by 2. So that a value, which is initial is 0, now it will be incremented by 1. So it is going to become 7. After that, it will go on to the next iteration. Now I value is going to become 2. Again this condition will become true, obviously. So now 2 modulus 2 not equals to 0. So 2 is divisible by 2. So that's why this condition is going to become false. When it is going to become false, it will come to the else block. Now what happens here? Now this b value is going to be incremented by 6. Initial b value is 0. Now it is going to become 6. Now I value is going to become 3. Now 3 modulus 2 is not equals to 0. Again, this is true. Now previously a value is 7. Now again we're going to add the value to 7. It will become 14. Now I value is going to become, so now already we have done 1, 2, 3. Now I value is going to become 4. Now 4 modulus 2 not equals to 0. So obviously this condition is going to become false. Now here we are going to increment the b value. Now it is going to become 12. Now I value is 5. If it is 5, now 5 modulus 2 not equals to 0. This condition is true. Now it is going to become 21. Now I value is going to become 6. This condition will become false. Now it will become 18. Now when it is 7, now I value is 7. 7 modulus 2 not equals to 0. Now again it's an odd term. Now we can call this as a equals to a plus 7. 21 plus 7, it will become 28. Now again we'll move on to the next iteration. Now again high value is 8. Now 8 modulus 2 not equals to 0, which is false. Now again this will be incremented by 6. Now it is going to become 24. So let's move on to the next iteration. I is 9. So 9 modulus 2 not equals to 0, which will become false. Now it will come to the else block. This condition is going to become true. Now a value is going to be incremented by 7. It is going to become 35. Now when it goes for the next iteration, I value is 10 here. Now 10 less than or equals to n. What is the n value? 9. So this condition is going to become false. Now it will directly come out of this for loop. Now when it is coming out of this for loop, you can see a value is 35 and b value is 24. Now here what we will do, we will check whether the n value, the given n value is 9 here. Now we're going to check whether it is an odd term or even term, right? Now a is representing the odd values and b is representing even values. So 9 is an odd value. So obviously we have to consider a value into the consideration. So for that purpose, we're going to check if n modulus 2 not equals to 0. So if it is true, that means this is an odd number. If it is false, it's an even number. So now 9 modulus 2 not equals to 0. Obviously, this condition is going to become true because it's an odd number. Now we can say that percentile d term of series is percentile d slash t. That means we're going to consider a value into the consideration. But if you look at the series, the initial values are zeros, but we haven't started with the zeros over here. If you look at this, what we have done initially itself, we have started from a plus 7. Like we are going to be one step ahead than the series. So that's why at the end what you have to do, I have to decrement the value by 7 to get the exact value. So that's why what we're going to do, a value is 35. So that's why what we're going to do, we're going to print the value as a minus 7. If you perform a minus 7, then it will perform 35 minus 7, where it will become 28. You can see the 9th term of the series is 28, right? So that's the important thing. At the end, we have to perform minus 7 if it is an odd number. We have to perform minus 6 if it is an even number. Why? Means we're gonna be one step ahead in the series to get the values. So that's why we have to decrement by 7 if it is an odd value. We have to decrement by 6 if it is an even value. I hope you understand this program. There are 2 more programs in this series and I am going to follow the same logic for them. Let's have a look at that, right? So let's try to run this program once and we will check it out. So let's compile and run this. So let's have a look at this series once again. This is the 9th term and this is the 8th term. 8th term is 18, right? So let's have a look at this. Let's say the given number is 8 and you can see 8th term is 18. So it's running fine. Okay then. So let's close this and let's close these. Let's close everything over here and let's move on with the next part of this number series. This is this different one where number series with a twist too. Let's have a look at this series now. Now this is 1 1 2 3 4 9 8 27 16 81. If you have a look at this series, you can clearly understand this is a form of geometric series, right? So where you can see this is like 1 2 and 2 into 2, you can see 4 into 2, you can get 8 into 2 16 into 2 32, right? Are you getting it? Now if you go to the even terms, 1, then you will get 3, then after that, so 3 into 3 you get 9, right? So it's a part of the logic that we have to understand that how does it work. So let's have a look at this program once. Right, now what we have done here, the same logic we're going to make use of for this program also. We're going to start off with main as well as I for the for loop, and n is the value that is given by the user. Initially in the previous program there were zeros, and here in the series we have ones, so that I am going to take a value as 1 and b value as 1, and I equals to 1, I less than or equals to n I plus plus. Just like the previous program, here also I am going to check whether it is an odd number or not. If it is an odd number, I am going to multiply with 2. If you look at this, the odd numbers are multiplied with 2, right? And if it is an even number, I am going to multiply that with 3. Are you getting it? Just like the previous program. Now at the end, I am going to check whether that n value, let's say n value is 9. If the n value is an odd number, I am going to take that a value into consideration. If it is an even number, I am going to take b value into the consideration. Just like in the previous program where we have performed -7 and -6 to get the exact value, because we are one step ahead in the series. So here we're going to perform multiply by 2 and multiply by 3. If we get the exact value, we have to divide by 2 and divide by 3. If it is an odd number, a by 2. If it is an even number, b by 3. Clear? So let's have a look at the 9th term of this series once. 1 2 3 4 5 6 7 8 9, which is 16. So let's run this program and check it out. What is the 9th term of this series is, right? So now here n value is going to become 9 and you can say 16. So it's working fine, right? So the same logic we're going to apply for this series also. So you can see in n number of programs, a number of competitive programs in the basic first round, we can see this kind of number series, right? So let's have a look at one more sequence here. Now this is a sequence where you can see 0 0 2 1 4 2 6 3 8 4 10 5 and so on. So now this is a mixture of two series, all the odd terms in this series and even terms in ascending order, and every even terms is derived from the previous term using the formula x by 2, right? So the same logic I am going to apply here also, but here you can see I'm going to perform +2 and +1 for the even and odd terms. If you have a look at this series, you can see for the odd terms I'm performing +2, 2 4 6 8 10 12 14 and so on. For the even terms I am going to add 1, right? 1 2 3 4 5 6 7 8 and so on. right? So you have to identify the series. How does it work? So initially here zeros, so that's why we're going to take a value as 0 and b value as 0, just like the previous programs. I'm going to take the same logic part. So for I equals to 1, I less than or equals to n, and I plus plus, and to determine whether it is an even term or odd term, we're going to make use of this condition. I modulus 2 is not equals to 0. If it is not equals to 0, it's an odd term. If it is an odd term, we're going to take a into the consideration. If it is an even term, we're going to take b into the consideration. At the end, again, we're going to find out whether the given term is even or odd. Just like the previous example, let's take it as 9. So I'm going, if it is 9, then it's an odd term. I have to take a value. If it is 8, it's an even term. We have to consider b value. Again, here also we will be one step ahead of the series. That's why if you are performing plus 2, here I have to perform minus 2 for the odd term and minus 1 for the even terms to get the exact value, right? So let's have a look at this one. What's so ninth term here? 1 2 3 4 5 6 7 8 9. Ninth term is 8, so that's why. So let's have a look at the execution part. So let's give that n value as 9, and you can say 8. So it's working fine here. So that's it about the number series program, which is the program number 3. Thank you guys. We will see you in the next video.